terminating a pull or spot circuit in a subpanel fed with aluminum wire is permitted. The National Electrical Code does not prohibit terminating a pull or spot in a subpanel fed with aluminum wire. Confusion sometimes arises with the connection of the equipment grounding conductor or EGC for the subpanel to the equipment ground bar. When the subpanel is fed with aluminum conductors, the equipment grounding conductor must be copper and sized in accordance with Table 250.122. The equipment grounding conductor must be connected to the equipment ground bar in the subpanel using an aluminum/copper compatible connector. To elaborate, it's important to understand the role of the equipment grounding conductor. It provides a low impedance path for fault current to return to the source. This low impedance path facilitates the operation of the overcurrent protective device such as a circuit breaker or fuse, quickly disconnecting the circuit in the event of a ground fault. The copper equipment grounding conductor is specified in this scenario to ensure a reliable and effective grounding path, mitigating potential hazards associated with ground faults in pull and spot equipment. Using an aluminum/copper compatible connector is crucial because directly connecting aluminum and copper can lead to galvanic corrosion. Galvanic corrosion occurs when two dissimilar metals are in electrical contact in the presence of an electrolyte such as moisture. The aluminum will corrode preferentially, leading to a weakened connection and potential failure of the grounding path. Aluminum/copper compatible connectors are designed to prevent this corrosion by providing a suitable interface between the two metals. These connectors typically use a plating or coating that acts as a barrier to prevent direct contact between the aluminum and copper. They may also be filled with a joint compound that inhibits corrosion. Table 250.122 provides the minimum size requirements for equipment grounding conductors based on the rating of the overcurrent protective device protecting the circuit. It is essential to consult this table to determine the appropriate size of the copper equipment grounding conductor for the subpanel. The table specifies the minimum size of the equipment grounding conductor in relation to the size of the ungrounded conductors. For example, if the circuit is protected by a 20 amp breaker, Table 250.122 might require a number 12 American wire gauge copper equipment grounding conductor. If the circuit is protected by a 60 amp breaker, a number 10 American wire gauge copper equipment grounding conductor might be necessary. Always refer to the specific edition of the National Electrical Code that is in effect in your jurisdiction, as requirements may vary. The equipment ground bar in the subpanel is the point where all equipment grounding conductors in the subpanel are connected. This bar is typically bonded to the subpanel enclosure, providing a common ground reference for all equipment served by the subpanel. It is essential to ensure that the equipment ground bar is properly bonded to the subpanel enclosure to maintain a reliable grounding path. The connection of the copper equipment grounding conductor to the equipment ground bar must be mechanically sound and electrically continuous. This can be achieved by using a listed connector that is specifically designed for this purpose. The connector must be properly tightened to ensure a secure connection. In summary, while the subpanel feeding a pull or spot can be supplied with aluminum conductors, the equipment grounding conductor within that subpanel must be copper and properly connected using an aluminum/copper compatible connector. Adhering to these requirements ensures a safe and effective grounding system for pull and spot equipment, reducing the risk of electrical shock and other hazards. Consider a scenario where a 50 amp circuit breaker is used to protect the pull equipment circuit. Referring to Table 250.122, you would likely find that a number 10 American wire gauge copper conductor is required for the equipment grounding conductor. This number 10 copper conductor must then be connected to the equipment ground bar in the subpanel using a connector listed for use with both aluminum and copper conductors. Failure to use a listed connector could result in corrosion and a compromised ground connection. Another important consideration is the proper installation of the aluminum conductors feeding the subpanel. Aluminum conductors require the use of antioxidant joint compound to prevent oxidation, which can increase resistance and lead to overheating. The connections must be properly torqued to the manufacturer's specifications to ensure a secure and reliable connection. It is also important to periodically inspect the connections to ensure that they remain tight and free from corrosion. In addition to the equipment grounding conductor, It is also important to ensure that all metal parts of the pool and spa equipment are properly bonded together. This bonding helps to equalize the electrical potential between these parts, reducing the risk of electric shock. The bonding conductors must be sized and installed in accordance with the requirements of the National Electrical Code. The National Electrical Code provides comprehensive requirements for the installation of electrical systems in and around swimming pools and spas. These requirements are designed to protect people from electrical hazards. It is essential to consult the National Electrical Code and any applicable local codes before installing or modifying any electrical equipment in or around a pool or spa. Proper grounding and bonding are critical for electrical safety in pool and spa environments. Failure to properly ground and bond electrical equipment can create a dangerous shock hazard. It is important to take the time to understand and follow the requirements of the National Electrical Code to ensure a safe and reliable electrical system. When working with aluminum conductors, it is important to use tools and equipment that are specifically designed for use with aluminum. This includes wire strippers, crimpers, and connectors. Using the wrong tools can damage the conductors and compromise the integrity of the connection. It is also important to be aware of the potential for galvanic corrosion when working with aluminum and other metals. As previously mentioned, galvanic corrosion can occur when two dissimilar metals are in electrical contact in the presence of an electrolyte. To prevent galvanic corrosion, it is important to use compatible materials and to protect the connections from moisture. In addition to the requirements for grounding and bonding, the National Electrical Code also includes requirements for ground fault circuit interrupter or GFCI protection in pool and spa areas. GFCI protection is required for most electrical circuits serving pool and spa equipment. A ground fault circuit interrupter is a device that detects small amounts of current leakage to ground. When a ground fault is detected, the GFCI quickly disconnects the circuit, preventing electric shock. GFCI protection is an important safety measure that can help to protect people from electrical hazards in pool and spa environments. There are several different types of GFCIs available, including circuit breaker GFCIs and receptacle GFCIs. Circuit breaker GFCIs are installed in the electrical panel and provide protection for the entire circuit. Receptacle GFCIs are installed in place of standard receptacles and provide protection only for equipment plugged into that receptacle. It is important to choose the appropriate type of GFCI for the application. In addition to the requirements for grounding, bonding, and GFCI protection, the National Electrical Code also includes requirements for the location of electrical equipment in pool and spa areas. Electrical equipment must be located at a safe distance from the water to prevent accidental contact. The National Electrical Code specifies minimum distances for the location of receptacles, switches, and other electrical equipment. It is important to consult the National Electrical Code to determine the specific requirements for your situation. The National Electrical Code is a complex document, and it can be difficult to understand all of the requirements. If you are not familiar with the National Electrical Code, it is best to consult with a qualified electrician. A qualified electrician can help you to ensure that your electrical system is installed in accordance with the National Electrical Code and is safe to use. Remember that electrical work can be dangerous, and it is important to take precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, it is best to leave the work to a qualified electrician. Proper grounding and bonding are essential for electrical safety in pool and spa environments. The use of copper equipment grounding conductors and aluminum/copper compatible connectors is crucial for ensuring a reliable and effective grounding system. Consulting the National Electrical Code and working with a qualified electrician are essential steps in ensuring a safe and code-compliant installation. Aluminum wiring requires careful consideration and adherence to specific installation practices. Always use antioxidant joint compound, properly torque connections, and regularly inspect for corrosion. While aluminum wiring is acceptable for feeding the subpanel, the equipment grounding conductor for pool and spa equipment must be copper. A copper equipment grounding conductor provides a reliable low-impedance path for fault current, ensuring the quick operation of overcurrent protective devices. Table 250.122 in the National Electrical Code dictates the appropriate size of the copper equipment grounding conductor based on the overcurrent protection. Selecting the correct size is critical for safety. In summary, the NEC permits terminating pole and SPOS circuits in a subpanel fed with aluminum wire, provided the equipment grounding conductor is copper and properly connected with an aluminum/copper compatible connector. Always consult the latest edition of the NEC and local codes for specific requirements.